Thank you so much for coming back today on our channel, The Physics Mindset, the only channel which is there to deliver for you information in electrical installation and electrical engineering, solar installation, and electronic repairs. As we are come from far from solar, we have done a bit of solar installations. Now we are entering into a history. We are still on an introduction to electricals or electricity. Okay, now you can't be an electrician, an engineer in electrical field without knowing atoms. The fundamentals, the moment you know what we call atoms. Today we are going to look at a topic which is atomic structure. We are going to study something about the atoms. Okay, because as scientists you can't do anything without this atomic structure, without knowing how electricity move from tiny fundamentals of electrical, or from tiny leads to the very big power plant. All depends on the movement of electrons. And to know the movement of electrons, you need to know what we call about the atomic structure. Without knowing the atomic structure, you can't know what electron is. Okay? We are going to study slowly, but we understand. So in future time, you will have to use these terms: the atoms, the protons, the electrons, the neutron. Once you know them, there it is good to go. You know the fundamentals of electrical engineering. So today let us jump into some of the technical questions under atoms. Question you can ask yourself. Okay? Like, have you ever wondered what electricity actually is? Or what electricity actually is? Okay? This question it sounds as if it is easy. What electricity actually is? People can say, no, I know electricity. But what is electricity? What are the fundamentals of electricity? Okay? Have you ever, now question 2, check. Why do electrons move? They are simple questions. Simple questions. Technical questions. But without knowing the atomic structure, you will never understand electrical. Okay? But once you know atoms, you will understand much electrical engineering. Mostly, the moment we are going in electronics, okay? Electronics will need to know, you need to know much about atoms. So that you can, scientists in chemistry, they go much deep into the periodic table. Whereby the periodic table, you will study all the structures, the number of valences, okay? The elements. Then you can calculate the chemical reaction of the components. Okay? Now, another question is, why is copper a good conductor of electricity while plastic is an insulator? Plastic or rubber, they are an insulator. But copper is a very good conductor of electricity. Why? Now, if you look at all these questions, these simple questions here around, which I have set, have you ever wondered what electricity actually is? Oh, why do electrons move? Have you ever wondered why electrons move from one place to another? Oh, why is copper a good conductor while plastic is an insulator or a bad conductor? All the answers of these three, all the answers begins with knowing what an atom is. Without knowing an atom, you will not know why electrons move. Or even you will not know what are electrons. Yet, in the fields of electrical engineering, without knowing electrons, you are missing something in your field. Okay? The moment you know electrons, meaning you have studied about atoms. The history, the hidden secret in electrical engineering is knowing the atoms. Okay? Now, let us see why is an atom so important in our day-to-day life. Remember, we said an atom is the smallest. An atom, should I write? Let me. Okay. An atom is the smallest unit of matter. An atom is the smallest unit of matter. What do they mean here? The smallest unit, matter, is anything that occupies space, as science say. Okay? Now, anything that occupies space, me myself, I'm occupying space around here where I'm standing, meaning I've occupied this space. I've become a matter. And an atom is the smallest unit of matter, meaning myself, I'm made of small atoms inside me, inside this body. This body is made up of millions of atoms, billions and billions of atoms. This marker which I'm using is because of the atoms, the smallest particle, because matter, anything which occupies space, there is space which this marker is occupying in this atmosphere. Okay, now it has become matter, and this matter is made of small particles. Which small particles are the atoms. Okay, this is the fundamentals. We are on the fundamentals of electrical. I want you people to become the true electricians, true engineers, that whichever topic you talk about, you have the solution to do in electrical installations, electronics. Mostly we are going in electronics, solar engineering. Be wide with the mind. Don't miss anything. So someone can talk about the atoms when you don't know. Fine, you know wiring. But do you know why a copper wire, do you know why you use a copper wire? Without knowing the atomic structure or the atoms, lessons on the atoms, knowing the electrons, the movement of electrons, knowing protons, neutrons, okay? It will be very hard for you. You will be an electrician, but not really the other one with conquer knowledge. There are some people with the true knowledge which we want in the world. And this is why our channel, The Physics Mindset, is here to give you the clear knowledge in the field of electrical, electronics, and solar engineering. Because we are going to start handling electronics without knowing atoms. They will be hard for you. No, so study the electronics. I'm going to give you brief notes about atoms so that you know about something about atoms, even though in the future time you'll talk about atoms. Okay? Now, since the atom is the smallest unit, or the smallest unit in the matter, all these things are made of small units, the matter, anything which occupies space. These are the transformers, the cables, those are matter, they occupy space, and they are made of smallest particles, atom. The lights, the bulbs, the TVs, the switches, the sockets, the main switch, all are made from particles. A combination of small particles, they make something which occupies space. Bricks, our houses, conduits, circuit breakers, all are made from atoms. Okay? Now, this atom has three main particles. As an atom itself. Let's have a structure for it, because all these questions we are asking. Why do electrons move? Why is copper a good conductor and plastic an insulator? Why is it like this? Okay? What really electricity is? All this comes within. You must understand what an atom is, then you can have the image into you that electricity, when electrons, without knowing an atom, you will not understand electron. Now let us see how we can understand an electron, okay, in the simple way. An atom, let's do a structure for an atom. An atom has three main particles, which are the three main particles of an atom. Particle in the nucleus, in an atom there is a neutron, 1, 2, there is a proton, 2, 3, it is electron. Electron, this is electron. This is where we are going to base most. In electrical engineering, we know this must. We always talk about electrons, okay? In electronics, electrons moving, electrical. All things come from an atom. Without knowing an atom, you will not know these terms. Proton, you need to know the proton, you need to know the neutron. Most don't only know electron, because this electron, it is what produces an electric circuit. When the movement, remember the definition of electricity. Without knowing this topic, you can't know electricity. These are the fundamentals. Once you know the atomic structure of the matter of the electricity, you know much electricity about the electrons. Once you know electrons, that the definition of electricity is the flow of or the movement of electrons in an conductive material. That is the definition of electricity. Now, without knowing electrons, how can you define electricity? You can't. Atomic structure. You need to know the fundamentals of electrical, which are these, which are looking. We are going slowly. We are reaching where you want. Okay? Soon we are starting the generation. Okay? Now, since this atom has three major particles, let's have a structure which can show us this. What are these major you know the cables? A wire occupies space. It becomes a matter. Anything occupies space. Okay? Now, this cable it's made of atoms, the smallest particles in a matter. Okay? Now, if you have a cable like this, a cable wire, inside this is the one end, another end. Now, this is a cable wire. Inside, let's say a copper wire. Okay? This is a copper wire. Inside this copper wire, when it was manufactured, they combined the scientists, they combined the physicists, they combined the elements. Which elements? Let's say on the elements in the periodic table. They pick some elements, they chemically mix it, and they come up with a cable. Which cable is it? A copper wire. And that chemical reaction of those elements, the chemical reaction, the chemical mixing, they mix these atoms to make a matter. They mix atoms, the smallest particles or the smallest unit in the matter. So this is a matter. A cable becomes a matter because it occupies space. Even myself, I'm a matter because I occupy space. Now, inside here, because it is made of atoms, it has electrons, negative charge, protons, positive charge, and neutrons. They are inside the cable. Okay? Because these atoms, you can't see them, we can't see them with our naked eyes, but only with a microscope. A certain type of microscope which can see these atoms, atomic reaction. Okay? check. Let us see if something, a structure for an atom. Let's have a simple structure which can show or demonstrate how an atom look like. Okay, I'm just giving you brief explanation about atomic structures. Okay, because it has these 3 major particles inside it, and it is the smallest unit of matter. You can't see it. It is the smallest. Even this, the marker which I'm using, is made of atom. Now, check. Since it has a nucleus, it has a neutron. Atom has a center which is called a nucleus. It has a center which is called a nucleus. Okay, let me name it. Nucleus. Now, inside the center of an atom, which is the nucleus, inside the nucleus, it is where we find protons, which are positive charged. They are holding a positive charge. These are the protons. We shall find there a proton with a plus, okay, inside a nucleus. Protons, it depends on which valency, how many protons are in an element. Elements, I mean, if you see the periodic table, those are elements, okay? Oxygen, hydrogen, lithium, argon gas, those are elements. They have numbers of protons. Now, still inside the nucleus of an atom, there is neutron. Neutrons are neutrons. They have no electrical charge. They are neutral. No electrical charge, not either positive or negative. We are digging how electricity came in. How we started to hear the word electron, electricity, the flow of electrons. That is the definition of electricity. So without knowing where electron came from, how can you know electricity? You need to know the fundamentals, the history. Okay? Now, inside the nucleus, we also have neutron. This one. Neutron, which are free. They are neutral. They have no electrical charge. But protons are positive charge. Now, there comes on another level, another layer, on top of the nucleus, and that is where we find, this is a shell. The inside shell, which is a nucleus, the outer shell, which is going to carry the negative charges, the negative electrical charges, which will be, let us see, we say a negative charge. And this is the electron, which moves from one place to another. And when voltage is applied on this electron, it moves from one place to another. Let's say it has like two electrons. Sometimes some elements have more shells with let's design something just to explain. A negative electron, negative charge, which is electron, negative charge, which is electron. And this is a shell, right? Now, this is the outer shell. There is an inside shell with the negative, and there is the outer shell. And this outer shell is the one which will return to be a valence, it will carry what we call valence electrons. These are the valence electrons. Valence electrons, which are negative charged. These valence electrons, because they are found on the outermost shell of an atom. This is an atom. Now there is a shell which is holding a negative charge. A nucleus is holding a neutron and a proton, a positive charge, which is a proton. The outer shell, the first outer shell is holding electrons. There is another shell, let us say it has another shell which is carrying still electrons, and electricity depends on this outer shell. And this outer shell, since it is the outer one, the most outer one, it is called, this shell, these are called valence electrons, and they are the one which we use to produce electricity. Okay, once we apply the voltage, okay, this is the voltage. You apply voltage on these electrons, they will move from one place to another. Let me try to give you a clear how we can explain this well. Okay, these are the valence. When we apply voltage on an atom, on the outermost shell, the electrons which are found on the outermost shell, which are the valence electrons, we have let us have something like a nucleus which is having a positive and a neutron, a proton and a neutron inside a nucleus. Now let me try to do some. When you apply this is an electron. If the voltage is applied on this electron, okay, it will move, but a nucleus will stay in one position, but electron will move because of the pressure. The pressure is the voltage. That is the definition of a voltage. The pressure applied to the current, which pushes the current to flow, and this current is the electron. This is the current. You see the word current, how it comes? Now, if you don't apply voltage, let us say a battery is a source of power. It has voltage. Now, let us do like this. This is our battery with 12 volts. Okay? Positive, negative. This is our bulb. Okay? Now we connect our cables on the positive terminal and the negative terminal. If you connect these cables on this source of power with a 12 volt is the pressure. The pressure is measured to be 12. That pressure is the one which is going to be used to push the current. In a cable, I told you, in a cable there is an atom. An atom which is having 3 particles: a proton, neutron, and electron. Now, the outermost electrons, which are called the valence electron, once the voltage is applied on these valence electrons, they will move. And once electron move, we said the movement of electron it causes an electric current to be generated, and that is electricity. We are defining electricity, but we are bringing how we define electricity, where electricity came from. What is electricity? You see all these questions, how we are defining the flow of the movement of electrons, what electricity actually is. Okay, why copper is a good conductor? Once you apply your copper wires on the bulb with the battery, a battery, I said, it has 12 volts. This 12 volts is the measurement of the force or the pressure. And which pressure? The word we use, technical word we use, is the voltage. That's why you find sometimes they can say high voltage and low voltage. The same, you can also say high pressure or low pressure. Now, if it is 12, let us say 12 is low voltage, okay? Once 12 volts is connected to the wire, a wire is made of atoms. It is a matter. An atom which is having electrons, protons, and neutrons. Now, since voltage is applied on these, they will move circle like this. The movement of electrons is it is the process of creating an electric, and yes, it in fact is a process of creating electricity. Check. Let me try to design. Let me try also to design here like this. Like this. Negative charge. Okay. These outer electrons will start moving. The nucleus will remain in one place. But the electrons, the valence electrons, once the voltage is applied in the cable, this reaction is happening in the cable, a copper wire, in a copper cable. That's why it's a good conductor. The moment these electrons move and the pressure is applied to them and they are moving, meaning there is also some resistance in the cable. That's why this 12 volts is using its 12 pressure voltage, the measured which is in volt, to push electrons. And once electrons move, electricity is produced or is created. And that is the fundamentals of electricity. That is where electricity, that is how we found electricity to be present. You need to know this. Technicians, electricians, engineers, or the beginners, students, you need to know these fundamentals. They will help you in future terms to describe, to know that, yeah, there is electrons in that cable. Use the technical terms. Okay? Now, these electrons, once they move around like this, the nucleus is in one place. Electrons are playing around. The valence electrons. Electricity is created. The bulb will light up. The cables, now it will be continuous. Continuous. And that's how we came up that the movement of electrons, the movement of these electrons, the movement of electrons is equals to electricity. Because electrons carry a negative charge and they are the one which move. And that is how electricity is found. Let us say some other things about the atomic structure, about the atoms. Okay, now, still we are looking at the atomic structure. I'm giving you brief explanation on the fundamentals of electrical engineering. Okay, because without this knowledge of atoms, you can't know where electricity started. Okay, you need to know the protons, you need to know the neutrons, you need to know the electrons. But we are basing much on electrons because we are dealing with electricity. Electron, the flow of electrons is the electricity. Okay, the flow of electrons in the cable is electricity. That's why cables are good conductors, because of this flow of electrons. Okay, now we saw, like, let's say talk about copper wire. A copper cable has valence. Remember, valence electrons, we said, are the outermost electrons which are moved when applied by the voltage. They move from one place to another, and that is what we call an electric circuit. A circuit, when there is a voltage, when there is electron moving, it means it is a good conductor. Okay. Now, a copper wire has something. It has, if you check on your periodic table, I don't know, a copper may be having one valence. One valence electron. Then there is aluminium. Aluminium has three valence electrons. So, which is good? Aluminium has three, meaning aluminium is good to transfer electrons from one place to another. That's why in our overhead lines, from the generation of the power to transmission, we are going to be using aluminium most. And we shall find mostly the copper might be in the transformers. But on our overhead, which I mean, because there is very many valences, meaning these electrons, the valence we are saying this is a nucleus. These are the valence, and we have others which move, and it's moving all sides. Okay, this is an atomic structure with negative. This is a proton, a nucleus having a proton inside, and it is not moving, it is held in one place. Okay, but for outer shells, for electrons, they are moving. Once the volts are applied on these electrons, once the volts in the cable, there is a battery, the source of power, which is the battery. Okay, battery is connected on the cable. This is a cable. Now inside the cable, there are very many atoms inside the cable, but this is just the structure of an atom. But an atom, a structure has a negative, which is the electrons, a negative charge, and a positive charge, which are protons, and neutrons, which are, they don't carry any electrical charge. Now, once these ones move round electrons, we shall have electricity in the cable. They knock themselves, they move knocking themselves. Okay, they have resistance. A cable has resistance. Okay, now since there are many, meaning the transmission of electricity from one pole to another pole will be very fast. Okay, though there are some resistance than copper wires. That's why we don't use, if this is one pole, okay, this is the ground. Now we have pylon, let's just say a three phase. Another pole is here. Just an explanation. Now this is live 1, this is live 2, this is live 3, live 1, live 2, live 3. Okay, now power, there is some earth. Okay, earthing is done here. This is earth wire. Now power, to move from one place to this pole, we use aluminium cables, because they have very many valences on their outer shell. Because once the cable has very many valences, they move very fast, the electricity move very fast. Okay, and you may find that it has less resistance in its characteristic. than a copper wire. A copper wire is good to install in the household. We use copper because of some of the basic properties. It limits the corrosion. Okay? It limits the corrosion, and our lighting will be fine in our sockets, switches, main switch. Copper also is not good. It has high resistance than aluminium. And that's why if we want to transfer power from one pole to another pole, we shall use the one which is having less resistance. Resistance, I mean something which limits current, which limits electrons to flow. Now, this atomic structure, it is inside the cable. This is one cable which is going. Now, inside that cable, this is the cable. Inside that cable, there is electrons, protons, neutrons. Okay? There are very many. Electrons, protons, neutron, protons. Okay? There are very many in the cable. They move slowly. Once the voltage is applied, once you apply the voltage on the cable, these electrons start moving to move from one place to another. And that is the flow of, we say the flow of electrons from one place to another is the definition of electricity. You see how interesting it is? Now, this aluminium has 3 valences. That's why we use it on transmitting our power from one area to another, from one village to another village in a long distance, because of the less resistance in it. Copper is very good, but has high resistance. Okay? Meaning we shall burn a lot of fuel to generate electricity when we are using copper to transmit electricity from one place to another. Because of the knowledge we got about the atomic structure, that, the aluminium has 3 valences. Meaning its reaction, the movement of electrons, is very fast. And copper has 1 valence, meaning the movement of electron is not very fast. And yet we want this power. That's why if you are on an eastern part of the country, this is the country, you are in eastern part of the country and this is west. The moment you switch on the main switch, on the dam, you switch on, someone here will receive. And the distance here, someone to travel from eastern side of the country to the western side of the country, you can take 1 day. But the moment we use aluminium with less resistance, these cables, okay, the overhead lines, the moment we switch on in the eastern part of the sun, you switch on, a switch on, power, the speed of power is like light, will reach in the western part of the country. Why? Because of the less resistance and because of the valences in the cable. Now, you can't know these valences, the valence electrons, without knowing the atomic structure. And this is the atomic structure. This is the fundamentals. You need to know these fundamentals, and electrical engineering will be good for you, will be so interesting, okay, in your journey of electrical engineering. Without knowing these fundamentals, you will not know why do they use aluminium, why do they use copper, just because of the valence, the knowledge about the valence electrons. Okay, and let us say an example of why they use these ones. Do you know someone, when you're running in a banana plantation, the one who is running in the banana plantation, remember you have trained for a year, 2 people. Now, one, you have the same pace if you're together on the free road. When the road is free, nothing is there. Now, when one is put in the banana plantation to run with the one who is put on the free road, clear road, who is going to be the first one to reach the ending point? The one on the clear road. Okay? And the one on the clear road is the aluminium, because of there is no resistance. It's just going straight. And the one in the banana plantation is the copper. Now, the one in the banana plantation is using much energy, but he needs to dodge the bananas, okay, so that he reaches the point. But the one on the Kiria road will run straight with no resistance, and that resistance is which resists this one going in the banana, running in the banana plantation. Because of the resistance, is going this side, but he's going in the one position with this one. But this one will reach faster, and this one will come later. And this is what I was explaining here. The resistance inside the cables, they limit the flow of current to move very fast so that it reaches the ending point. That's why if you switch the switch, when you're using aluminium and you switch on in the eastern part of the country, within a second, millisecond, someone in the western part of the country will receive electricity just because of aluminium and its valences. You see how to study about atoms is helping us. It's giving us why they use aluminium in transmitting the electricity from one place to another. Okay, and these copper wires are very good in the short distance, that is installing our houses, because they have that resistance which is good conducting for our gadgets, lights, TVs, fans to work on. They carry the exact amount of power. They bring it to our TVs. If it is 240, it will be 240 in our TVs. Okay? And these aluminiums, they may change. That's why they put transformers. After some distance, they put a transformer to step up. Okay? Either step down or step up. If you have generated, let us say, a three-phase of 410. The moment from this pole, it will reach on this pole, it may be, here it is 410. The moment it reaches, when it is longer distance, it can reach 405. Meaning there is some voltage drop. And this voltage drop, this is because of the resistance in the cable. But the resistance is not too much. Let's say if you are using copper wires, the moment you produce 410, you transmit it to one place to another. Here it can reach when it is 350 because of the high resistance in the cable of the copper and less valence electrons. Okay? Now, since the electrons are very many, they are fighting that resistance. But if the valences are very few, one, the fight is going on and electricity will drop, will have high drop. Okay? And this is how we have come up with the atoms, some knowledge about atom. I wanted you people to know where we are going as we have started the electricals. We need to know. I don't want us to leave anything back. The moment we go front, we know where the fundamentals are. The people who discovered, electricity, I told you, no one invented it. They just discovered it was already in nature. Okay? After knowing this, then in the next video we are going to study about the insulators and the conductors. So we shall go much into the insulators and the conductors. Insulators, which are good conductors of electricity, and insulators are bad conductors of electricity. In the next video, don't miss, because we are moving slowly as we go. I want you to know the physics. As our channel, the physics mindset is all about the physics knowledge in electrical, electronics, and solar engineering. Thank you for watching. See you in the next video about the insulators and the conductors. Okay? Don't miss, because it is good for you. Thank you. See you there.